given what we just learned and your table as a reference, I want you to try this one on your own, which means in a moment after I read it, I'll ask you to pause and really try it on your own before you hit play again. At the county fair, Andy found a game in which the player would toss a pair of standard dice. If the dice showed a sum of 2, 3, 4, 5, 10, 11, or 12, the player would win a prize. If the dice showed a sum of 6, 7, 8, or 9, the player would lose. Andy decided to play since he thought his chances of winning would be greater than his chances of losing. His reasoning was there are 7 chances of winning, all of these possible sums, and only 4 chances of losing, these 4. There's something wrong with his reasoning. See if you can explain what's wrong with his reasoning while you pause. I don't expect you to do it in the 3 seconds that I paused. I paused for 3 seconds so you can hit pause. So I assume you did, and I assume you tried this. And if we go back to our table, okay, I did a little edit and moved the table that we made on the previous slide onto this slide. If you refer to all the ways of getting these different sums, you can figure out the probability of winning. There's 36 possible dice rolls, different ways those 2 dice can land. But the winning sums, the 2, 3, 4, 5, 10, 11, and 12, if I just get a highlighter really quickly. 2, 3, 4, 5, 10, 11, and 12. That's 16, it looks like. If I counted right. 6, 12, yeah, 16 ways to win. Which means the probability of losing, we don't need to count the losing sums because we know these have to be complementary. We talked about complementary events. Either one or the other has to happen. Based on the rules of this carnival game, you're either going to win or you're going to lose. So if the probability of winning is 1636, you can be sure that the probability of losing is 2036. Because even though there are only 4 sums with which you lose, there are many more ways for those sums to come up when you roll the dice, or those sums are more probable, much more probable, especially the 7. I think actually the 6, the 7, and the 8. Now you would still have to throw in something else to make it. But this is how carnival games work, by the way. They make something look attractive, look like it's to your advantage, but it never is, which is another good reason to understand math. If you go in knowing I'm doing it for fun, but I know the odds are slightly against me, that's one thing. But if you go in thinking the odds really are in your favor, and you don't know how to do the math, that's a kind of an unfortunate situation.